Chapter 9 Thermochemistry, Exercise 9.69. When 1.37 grams of biphenyl undergoes combustion in a bomb calorimeter, the temperature rises from 24.9 to 31 degrees Celsius. Find this internal energy of reaction for the combustion of biphenyl in kilojoule per mole. The heat capacity of the bomb calorimeter is this much. Alright. Now we have the heat capacity of the bomb calorimeter, 5.86 kilojoule per degree Celsius. This means to increase the temperature by 1 degree Celsius, we need this much heat, 5.86. Over here we have the actual temperature change, 31 minus 24.9, and then times this will get the amount of heat in kilojoule. And finally we need to use kilojoule per mole, right? So the total amount of heat by multiplying this delta T and this heat capacity divided by the number of moles of biphenyl will get the final answer. We do not have the number of moles, we have the mass of the sample. So we do need the molar mass of biphenyl. Carbon is 12 grams per mole, hydrogen is 1 gram per mole. So it's going to be 12 times 12 plus 1 times 10. I think you'll get 154 grams per mole. And we can use 1.37 grams divided by 154 grams per mole to get the number of moles. Alright, now let's set up the equation in the calculator. This delta E of reaction is, I'm not sure if I can type delta. No. So I'll just type delta. Delta E of reaction. Alright. It equals the amount of heat divided by the number of moles. Alright. So Q over N. First, let's compute Q. Q is negative for biphenyl because this biphenyl undergoes combustion and releases heat. So this is negative number. We do have this bomb calorimeter absorbing heat. So for the calorimeter, Q is positive. This is the heat capacity for bomb calorimeter, and we have temperature change. Again, on top we have a negative value because this is the amount of heat released from biphenyl, and it means biphenyl loses energy. Okay, bottom, the number of moles. We have 1.37 grams divided by the molar mass. Carbon is 12, and we have 12 carbon. Hydrogen is 1, so we have 10 hydrogen atoms. So this is the setup, by doing this calculation we will get the internal energy of reaction for the combustion of biphenyl in kilojoule per mole. A few things. First, on top this is negative because biphenyl loses energy. And number two, on the bottom we have the number of moles of biphenyl. Alright, grams over molar mass. To use the calculator, I think I need to do this. So negative 4018 kilojoule per mole. Oh, 3 stick figures. So it should be negative 4.02 times 10 to the power 3. Now let's look at this calculation. It's Q of reaction, which is negative, divided by the number of moles of biphenyl. And the Q of reaction is negative Q of this calorimeter. They use CAL to denote the bomb calorimeter. Q of the calorimeter is the heat capacity of calorimeter times delta T. On the bottom, we have the mass over molar mass. That's it. And I'll show you my calculation here as well.